Welcome to the second tutorial, Terrain and Dynamic City Layouts. In this first part we are talking about the creation of terrains. So I went already ahead and I created a new scene. So let's check out what we have in the Maps folder. As you see here, we have three different images. There's one which is called elevation.jpg, so I'm gonna just drag and drop this into the viewport. This automatically triggers the terrain dialog, so when you drag and drop an image file into the viewport, CityEngine assumes that you want to create a terrain. Now we see two entries here. One of them is the height map file and one of them is the texture file. So let's quickly change the texture file, which is usually a satellite picture or something similar, and now it makes more sense to you. So all the black areas are, exactly black areas, they are 0 meters above sea level. All the white pixels, those are at the moment 100 meters. Let's change this to 150 over sea level. So all the values between are interpolated, and then the texture file is just mapped on top of the terrain. So it is obviously important that the extent, that the physical dimensions of the displayed area are equal in both of these images. Now, as we have said, the brightness is sampled, so black and white pixels, and they are mapped in this range here. So let's go in and make adapt the values here. So since this is not a geo-referenced image, we have to manually enter a value here. The values which were shown before, they are the image resolution, which is fine for this current example here. But obviously if you would have a geolocated image or a DEM, like for example a geotiff, the values will get interpreted for you and filled out in this dialog. So let's go ahead and finish this image map and hit the A key to frame all. Now we see there's actually indeed going some elevation is going on here, so it seemed to have worked. So let's select the layer here and open the inspector a little bit more. So the inspector usually shows all the most important information about the current selection, which is in the current case the terrain. So we still see the bounds and the offset here. There's more to it, so you can go in and, for example, play with the alpha of the terrain. You could add in an offset for some tricks and ways, or yeah, sometimes you need this to move the terrain up and down without altering all the other values. So this is neat from time to time. Then the layer attributes here are also very important, and here you see that for example the U and the V subdivision still use the same resolution as the incoming JPEG file in this case. So let's go in and visualize this a little bit more so it makes more sense. So first let's activate the wireframe alpha here. So here you can make this about 0.2, and then when we zoom in we actually see all the polygons, so before and after, and like this it makes more sense. So we can go in and change this to maybe 50 and 50, and now you see that the terrain gets created much more coarse, but obviously it has much less geometry or much less polygons. So you can go ahead and play with these values and yeah, use it or use as few polygons as possible. Down here we have a little bit of CGA code, which is the elevation. So this attribute gets read by the actual image, and all of this data here, so the attribute which was created, can afterwards be used in CGA for the creation in your 3D models. So for example, this can be used to distinguish whether a bridge should be created or a street because of the height above floor or something like this. In this second part of the tutorial, we are again going to grow some streets and talk about the obstacle maps. So let's go in and trigger again the Grow Streets dialog. Now under the environment settings, what we can do is, or it was done already automatically here, is CityEngine took the actual terrain. So we can choose the height map and use this as an input for the Grow Streets dialog. So again, I'm going to grow some streets here, close the dialog, and now we see that all the created streets are actually following the terrain curvature. So this is actually a great handy feature which saves you quite some time when you have to, or because you don't have to align the streets again in a second step. About aligning, we're coming back to this in one of the next parts of the tutorial. Now we see that in this region here we have a lake, or so this blue area here is supposed to be a lake. So we don't want to have any streets going into the lake. So let's go ahead and fix this problem. So we're going to delete the street network again and go in and create a so-called obstacle map. For this we are going into the layer dialog. It seems that it's cut off a little bit by the video, but let's just continue. New map layer and then obstacle map. And now let's go ahead and select this obstacle map here. As you will see in the preview, it is actually a black and white image, or black and white pixel image, and there's a threshold which can be set. So 0.5 again is the brightness. This basically tells in which regions of the city, whether in the black areas or in the white areas, streets should actually be created or not. So let's force again the same extent and create finish. Now let me quickly hide the terrain layer and select the obstacle layer. Now in the inspector you see again the CGA code, which is automatically created for you, which samples the image brightness and puts all these attributes into this it puts all the values into this attribute called obstacle. And this again can be used by the Grow Streets algorithm. So let's go in and trigger the dialog again. And now in the environment settings we can also choose the obstacle map. So let's create or hit apply again and go and see that the system actually tried really to avoid all of these areas which were inside the lake area, which was blocked out by the obstacle map. In the third part of the tutorial we are talking about the cleanup tool for the street graph segments. So it can happen that depending on how the graph segments are layouted or how they lie in the scene, not always the dynamic city layout system can produce a correct set of shapes for them, as within this example here. So the red line actually indicates the graph segment which causes the issues. So we could manually go in and select this node here and move it out of the way so that the shapes actually can be produced correctly. But depending on the amount of segments you have in your scene, or the amount of time you want to spend cleaning those data sets, it may also be useful just to use the cleanup tool. So let's select this group of street segments and fire up the cleanup tool. This here is the button. You can also start it from the graph menu. So let's go into the cleanup graph tool. Now a few settings are available You may want to read the documentation on what these settings do precisely. I'm just gonna activate all of these options here, so we also get some intersections and some merging going on, and I'm going to use a default radius of about 4 meters, which is usually a good value. And I'm going to hit finish, and as you see, CityEngine resolved this problem here properly. Obviously it had to change some of the input graph network, but at least the conflict is now history. In this fourth part of the tutorial, we are talking about aligning elements in the scene. So we are talking about aligning graph segments and shapes and the terrain itself. So one of the first things I wanted to quickly mention is there is a difference between so-called static shapes, which were either imported or drawn manually with these tools up here, or there are the so-called dynamic shapes, which are produced by CityEngine's dynamic city layouts system. So all of these shapes are dynamically created, and there's a little difference in the alignment, so I'm gonna talk about this in a minute. So this is just an important distinction in the naming of the elements. Okay, so let's assume we wanted to align some new streets to the terrain. So let me make a little bit an example, and let's say we had just created these streets manually and we wanted to align them to the terrain. So how would we go ahead and actually do this? So I would select all of these graph segments here and then go to graph, align graph to terrain, or you can do the same thing here with this little button. And then a window pops up and you can define how you want to project all your graph segments. So in this case we want to project them onto the terrain, and we can even also add an offset. So I'm going in and putting in 0.2, and this puts them a little bit above the terrain. Let me hit finish. And now you see that all of these graph segments have been projected down. So let's continue now with the static shapes here. So let me select these guys, and for those there's also specific button here in the GUI. So let me use the align shapes to terrain dialog. Now here there's multiple possibilities. On one hand side you can project so that each point is individually projected down, or you can translate, and this just basically moves the whole shape up or down, but it keeps it in this case planar. So let me just use project all for the moment and also go ahead, use the terrain and a little bit of an offset again. Now you see that these shapes have been projected onto the terrain. So now the special case with the alignment of dynamic shapes, since those shapes are always produced dynamically when I'm moving some of the streets or the street graph segments, the alignment is not really done with projecting the shapes themselves, but the alignment is in this case handled in the block subdivision settings. So let me select the block as I just did, and then here there is an alignment parameter. Here you can say uneven, even at minimum, even at maximum, or average. So that's a little difference. Now there's one type of alignment left, and this is actually realigning the terrain back to shapes. So in this case what I would do is I'm just selecting here all the shapes, and then I'm going to this button here, align terrain to shapes. This opens another window here, and then I can specify my terrain. I could also align all the terrains which I have hidden in the scene, for example, and then let me actually change this to 100 meters and leave the rest at the default and just go in and hit apply. Now you see that it may be hardly visible in this specific example, but let me go in and activate a little bit the wireframe here, and again go in and hide the shapes. Yeah, here you see it. The terrain has actually been aligned to all of the shapes which were selected. And now let's go in and select the terrain layer again and click this button here, the Enable Elevation Data. What does this mean? You see, when I activate it and deactivate it, you see that the terrain changes back and forth between two states, and these two states are actually without the alignment and with the alignment. So that must mean that the data or the delta between the two states is somewhere stored, and this actually is stored in the data folder in here. But for this to actually be stored or be visible at the first time, you have to save the scene. So let's go ahead and save the scene, and then go in here and refresh this folder. Now I have aligned the data already in two of the scenes here, so there are two different delta maps available. As you see that the data is stored in a subfolder of the data folder, which carries the exact same name as your scene file, which is in the current case Street Tutorial 02, which I have open. Now if I'm opening this file, it looks about like this, and you see that the alignment was actually done by moving some points up and some points down, and this is stored in this 16-bit PNG file. That's it for this part of the tutorial, so let's continue with the next. In this last part of the tutorial, I'm talking a little bit about dynamic city layouts. Dynamic city layouts is CityEngine's own system for the creation of blocks and streets and the whole block subdivision. Now, this is usually used by users who want to just create large portions of, for example, fictional cities, where they just grow some streets, or they don't have access to GIS datasets, or they just want to use the interactive nature of the dynamic city layouts because they are just much faster to edit the streets that way. Now, when I'm going in and selecting this part of the street network which I have grown before, we see that there are 4 types of elements involved. So let me hide the shapes here for a second. Now we see all those black dots here. They actually represent a node. So then we also see the lines here. These are actually the street segments. So obviously each street segment ends and begins with a node. So these are actually always connected. Then the next element, the third element, is actually a block, which is always represented with this dashed line. Now all of these elements have some parameters, so if we select those and check out the inspector, we see that all of these entities have specific input parameters, and depending on how these are set, the shape creation is adapted. So if we go in and, for example, edit the width of this street here, the geometry of the street is adapted, plus the block right next to it is also adapted. So let's find out. Let me quickly create a block here. Let's find out how a block is actually generated. So we see that when I'm connecting a road network and we have now a fully enclosed area, a block is automatically recognized and subdivided by CityEngine. So we could also go in and deactivate, for example, the shape creation and just work with the streets, or we can work with the block and play with its subdivision. So there are different types to use to choose from. We have, for example, the recursive subdivision, which just splits the block shape down into smaller bits. Then we could use the offset subdivision, which makes this ring which goes around the block, or we can use the skeleton subdivision, which is usually very prominent, for example, in suburban areas in America. Okay, let's talk a little bit more about the shape or the street creation. For this we have two specific tools. The one is the polygonal shape creation and the other one is the freehand street creation. So you can go in and just really paint some streets here and design your own city layouts that way. Now there are also settings for this under Graph, Street Creation Settings. There's this window where you can set all the default behavior, like the default street widths, and for example when blocks are generated you can choose the subdivision type and which rule should be applied. So let's talk a little bit about the other tool called, which is found here by the way, the Edit Street tool. You can also hit the C key on the keyboard. So let's do that. Now the Edit Street tool lets you edit multiple things at the same, or not at the same time, but within the same interface with handles. So you can go in and interactively edit the height, the width of the street, for example, and you see that it is the same parameter as in the inspector, but it is maybe a little bit more intuitive. So you can also go in and edit the horizontal handles when you look down, and if you're looking at a more glancing angle you can also edit the vertical tangents. Now you can also go in and, for example, select these two street segments here and play with the precision, which subdivides the shapes rather coarse or rather fine, and that is completely up to you. Now you can also, for example, play with the nodes at intersections, so you can select this node here and change the type from crossing to junction or even to roundabout, and play, for example, again with the tangents or play with the radius. Now there's also at the end of the streets you can also trigger a roundabout, which is basically the geometry for a cul-de-sac, so basically a street end. Okay, that's it for this tutorial, and I would recommend you to watch the other tutorials too. I hope you learned something, and see you next time.